Now practice more than 1.5 lakhs questions to crack JEE, NEET on PracBee practice app. Download now.
So now let us study a new concept in which we will study river problem, right? Have you heard of river problems? A man has to cross the river, in which direction he should swim, such kind of a questions?
Yes.
Okay. So first of all, let us study one dimension, right? One dimension you have studied in class 10th, right? Upstream and downstream velocity. You must have studied in mathematics. There was an equation of motion, right? Oh, sorry, when we have linear equations. Okay. Suppose we have a river and there is a person which is swimming in this direction, right? And this the velocity of the stream is u. U is velocity of river, right? And v is velocity of man with respect to river, right? What does it mean? If the river is not flowing, in that case the velocity of the man will be v. Okay.
Yeah.
So suppose there is a person who is standing on the bank. Okay, with respect to this observer, the velocity of this man is going in downstream, right? When you flow in the direction, if you swim in the direction of the flow, then that is known as downstream. If you flow against the direction of the flow, then it is known as upstream, right? So velocity downstream will be v plus u, because velocity downstream is the velocity of the man with respect to a person who is standing on the ground, right? So he'll find that man is going with a speed of v plus u in the right direction, right, Siddharth?
Yeah.
And velocity upstream will be v minus u if a man goes in this direction, right? That will be upstream. So this is your downstream, and this is upstream. Clear? So let us do a question. Say we have, this is our river and there is a point A in the river, fixed point, and there is a point B, fixed point, right? In the river. A man starts from A to B and then from B to A, right? You have to find the average speed of the man. Man go from A to B and then from B to A. So you can say he goes downstream from A to B and then goes upstream from B to A. So what is the average speed? So let me write, a man swims downstream from A to B, then upstream from B to A. Find average speed of the man. Clear? We have given let us see what we have given. We have given v, which is velocity of man with respect to river, right? And u is the velocity of river. Right. Okay, so now let us see two-dimensional problem. Okay, so say a man or a swimmer starts from A, and this is the point B, which is directly opposite to A, right? On the other bank. River is flowing in this direction with a speed u, and we know that velocity of swimmer or man with respect to river is given as v, right? Okay. The magnitude of that is this, and the magnitude of the velocity of river is u, right? And the width of the river is given as d. Okay. Suppose if the man swims at this particular angle. So this is the velocity of man with respect to river, right? So he wants to reach at this particular point, but because of the river velocity, there will be a velocity in this direction, that is VR, and your swimmer will end up at some other position, right? Is it clear? Swimmer orientation was along VMR, but actually he travels along this particular green line. So let me draw the orientation. So swimmer was like this. Is it clear?
Yes.
So his orientation is along VMR, but he is going in that particular direction, right?
Hmm.
So we can say velocity of man with respect to ground will be velocity of man with respect to river plus velocity of river. Is it clear? By triangular law of vector addition, you can see that this is your VM, right? Right, Siddharth?
Yes, sir.
So the resultant of VMR and VR will be the velocity of the man with respect to the person who is standing on the bank or with respect to ground. Okay. Now, if you want to find what is, say this angle is theta. Say this angle with the flow is theta. Okay. Right. If this angle is theta, so now we have to find what is the time taken by the man to cross the river. So it will be V cos theta I cap plus V sin theta j cap. And what is VR? VR is U I cap, right? So we have V cos theta plus U I cap, and we have V sin theta j cap, right? Now you can see that it has two components, one in the x direction, another in the y direction. Now this y component will be responsible for crossing the river. Is it clear?
Yes.
This responsible for crossing river. This component provide drift, right? What is drift? Drift is this distance. Okay, so this is your drift. So x component of velocity will be responsible for drift and y component will be responsible for crossing the river, right? So if you want to find the time, so time to cross the river, say t, it will be width divided by velocity in that particular direction, that is v sin theta. Is it clear? Now if you want to find what is drift, so drift will be your time, which we have calculated speed into time in the x, v cos theta plus u into d upon v sin theta. Is it clear? So I multiply time with the velocity in the horizontal direction. Okay.
Yes.
Okay. So now let us see some important cases. So very first case, if v is greater than u, okay, velocity of man with respect to river is greater, the magnitude of that will be greater than the velocity of river. In that case, if you want to find the shortest time to cross the river, right? Right. So this is your time to cross the river, right? If you want to minimize this, we have to maximize sine theta, right? Because it is in the denominator. So time to cross the river in shortest time will be d upon v. Is it clear? So it means your theta has to be 90 degree. So a person has to jump or swims at a right angle to the flow. Is it clear? Okay, so in order to cross the river in the shortest time, we have to, the time should be this d by v, and the person has to travel at an angle 90 degree with the flow. So now suppose we want to find time to cross river along shortest path. right? So this is A, this is B. Now we want to reach B, right? So it means your VM should be in this direction. In order to achieve this, the person should swim in this particular direction. Clear? And there will be a river velocity in this direction. Now let us say this angle is theta, right? Angle with the flow in which the person swims, right? Now we have to find this theta. In that case, the person crossed the rivers along the shortest path, right? Okay. So first of all, what is this angle theta? So we have a right angle triangle, right? Okay. So let us say this angle is phi. So this is V and this is U, right? Okay. So your sine phi will be U by V. And what is cos theta? Or what is theta, right? So we know that 90 degree plus phi will be equals to theta, right? So if I take sine on both sides, so we have sine 90 degree plus phi sine theta, right? Or you can say simply if I take cos theta on both sides. So let me take cos theta on both sides. Sorry, cos. So it will be minus sine phi, right? What is sine phi? U by V. So minus U by V will be cos theta. So theta comes out to be cos inverse minus U by V. So we have found what is angle theta, right? Now, what is the time taken to cross the river? Time from A to B will be distance. That will be D divided by speed in that direction. So it will be V your sine theta. Got it? Vertical component of VMR. It will be sine theta, right? Horizontal component will be cos theta. Vertical will be sine theta.
Yes.
So let us put the value. So we have D upon V sine theta will be what? It will be square root of 1 minus U square by V square. Is it clear? That will be D and that will be square root of V square minus U square. Got it? Or you can clearly see that your VM is nothing but square root of V square minus U square. Got it? So this will be the time to cross the river along the shortest path, right? So we have seen two important cases. In order to cross the river in the shortest time, the shortest time will be D by V and the angle will be 90 degree, right? So let me draw here. Okay. So this is A, this is B, and this is C. So person will reach at C, right? So there will be some drift. And your drift will be, in this case, your drift will be your U times the time, right? Got it? Okay. And in this case, we have found what is the time and at what angle the person should swim, right? Okay. Right. So now let us see another case. So now you can say when the velocity of man is greater than the velocity of the river, in that case the drift can be zero, right? So in this case the drift is zero. You can see that person is reaching at B.
Yes.
Okay. So now suppose if second case will be if V is less than U, right? Flow is very high. A person's speed is less than the flow speed, right? So in that case, what will happen? In that case, the drift can never be zero. If a person swimming in this direction, right, against the flow, and the flow speed is more, a person must be having a net velocity in the direction of the flow, right?
Yes.
So the drift can never be zero. So in this case, let me write here. Now what we are going to do, say when the man goes in this particular direction. So this is the velocity of man with respect to river. And this is the velocity of river, right? And this is A and this is your point B. and man goes in this particular direction. So this is the velocity of man, right? And this is your x. Clear? And this angle is theta. Angle made by VMR with the flow, right, is theta. So basically that is the orientation of the person. So if a person standing on the ground, he will observe that the person is going in this direction, but he end up at this particular point. Right. So now, what is x? We know that your VMR, its magnitude is V, and your VR, its magnitude is U, right? And your velocity in the x direction, or you can say your drift, will be V cos theta plus U into time, distance, upon speed, which is V sin theta. Is it clear? So this is our drift. That is a general formula, right? That we have derived. Same formula. Now, let us differentiate this because we want to find the minimum value of x, right? So we will use maximum minima. Do you know the concept of maximum minima?
Yes.
So you can differentiate this. So let us differentiate that. So we have dx by dt, dx by d theta, right? Now we can apply a quotient rule, right? Differentiation of the numerator. Differentiation numerator will be v minus sine theta. Denominator as it is, right? Let me take it v here. Sine theta minus numerator as it is. Differentiation of the denominator, which is cos theta. Clear? Divide sine square theta, right? Okay, so now we have to put this thing equals to 0. Okay, so we have minus v sine square theta minus v cos square theta minus u cos theta divided by sine square theta, right, equals to 0. Okay, so theta can never be 0, right? Is it possible theta can be 0? If theta is 0, the drift can never be minimum, right?
Yeah.
So this is a positive quantity, right? Yeah. If the left hand side is 0, so the numerator has to be 0, right?
Yes.
So we have minus v minus u cos theta comes out to be 0. So cos theta comes out to be minus v by u. Clear? So now we know what should be the angle, right? So theta will be cos inverse minus v by u. Clear? Now you can see quite similarity in this formula and the formula that we have done for this, right? Okay, here we have u by v, here we have v by u. So you can say the numerator is smaller and the denominator is larger. Same is the case here, right? U by v, where u is small, v is large, right? Okay, just remember this formula. So if you substitute cos theta as this, we can get the minimum drift, right?
Yes.
X minimum happens at theta equals to cos inverse minus v by u. Clear? Now you have to substitute this value in this and you can find the answer, right?
Yes.
Okay, so let us quickly find the answer. So X minimum will be v minus v by u plus u, and then we have d upon v, and this will be square root of 1 minus v square by u square. Clear? So we have minus v square plus u square divided by u, and there is a v in the denominator, and d divided by u square minus v square, and there will be a u in the numerator, right? So this u will get cancelled out with this. So we have d upon v u square minus v square divided by square root of u square minus v square. Clear? Then you can further simplify this and you can write this as d by v. So if you rationalize the denominator, right, So we will get square root of u square minus v square. Clear? So that is the answer. So let us see a case question. A boat moves relative to water with a velocity v,
Hmm.
which is n times less than the river flow. Right?
Hmm.
So velocity of man with boat with respect to water, or you can say velocity of boat with respect to river, right? Is it is given as v, and this is n times less than the velocity of river u. So it is u by n. Is it clear?
Hmm.
So it means u is greater than v. Clear? So flow is greater than the speed of the boat with respect to river. At what angle to the stream direction must the boat moves to minimize the drift, right? At what angle to minimize the drift? So you know the condition, right? Cos theta will be minus v by u.
V
Got
by
it?
U.
And what is v? V is u by n, right? Right? So theta comes out to be cos inverse minus 1 by n. That is the answer.